Researchers at Aalto University, Finland have developed a new device for spintronics. The results have been published in the journal Nature Communications and mark a step towards the goal of using spintronics to make computer chips and devices for data processing and communication technology that are small and powerful. Traditional electronics uses electrical charge to carry out computations that power most of our day-to-day technology. However, engineers are unable to make electronics do calculations faster as moving charge creates heat and we are at the limits of how small and fast chips can get before overheating. Because electronics can be made smaller, there are concerns that computers won't be able to get more powerful and cheaper at the same rate they have been for the past 7 decades. This is where spintronics comes in. Spin is a property of particles like electrons in the same way that charge is. Researchers are excited about using spin to carry out computations because it avoids the heating issues of current computer chips. The device the team made is a Fabry-Perot resonator, a well-known tool in optics for creating beams of light with a tightly controlled wavelength. The spin-wave version made by the researchers in this work allows them to control and filter waves of spin in devices that are only a few hundreds of nanometers across. The devices were made by sandwiching very thin layers of materials with exotic magnetic properties on top of each other. This created a device where the spin waves in the material would be trapped and cancelled out if they weren't of the desired frequency. The issues with speeding up electronics goes beyond overheating. They also cause complications in wireless transmission as wireless signals need to be converted from their high frequencies down to frequencies that electronic circuits can manage. This conversion slows the process down and requires energy. Spin-wave chips are able to operate at the microwave frequencies used in mobile phone and Wi-Fi signals, which means that there is a lot of potential for them to be used in even faster and more reliable wireless communication technologies in the future. With spin waves, the information is carried in the amplitude of the wave, which allows for more analog-style computing. This means that it could be very useful for specific tasks like image processing or pattern recognition. Now that the team has the resonator to filter and control the spin waves, the next steps are to make a complete circuit for them.